Welcome to the session on radians, arc length. The objectives for this session are to find an arc length using radians. Recall that the measures of angles in degrees are defined by 1 degree equals 1 out of 360 of a revolution. Angles can also be measured in radians. Pi radians equals 180 degrees. Using radians simplifies the formula for arc length. So suppose we have a circle with arc length L and radius R. The angle theta in radians is contained by the sector denoted in the diagram. The arc length L is equal to R times theta. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We are required to calculate the length of the arc of a circle of radius 6.3 centimeters, given that the arc subtends an angle of 0.7 radians at the circle center. So here's our diagram. We have the length of the arc of a circle here, L, we know that the radius is equal to 6.3 centimeters, and the angle theta is equal to 0.7 radians. So the arc length L, which is equal to R times theta, is equal to 6.3, which is the radius, multiplied by 0.7, which is the angle theta. Giving us that the arc length is equal to 4.41 centimeters. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. A circle with center O and radius 8 centimeters has arc length AB equal to 12 centimeters. Calculate the size of the angle AOB subtended by the arc at the circle center. So here's our sector. And here's our angle theta. We know that the radius is equal to 8 centimeters. The arc length is equal to 12 centimeters, as shown. We can rearrange the formula L equals R theta to give us that theta equals L over R. And then substituting in the values gives us that theta equals 12, where 12 is the arc length, divided by 8, where 8 is the radius. And therefore theta equals 1.5 radians. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. A circle with center O and diameter d centimeters has arc AB. The perimeter of AOB is p centimeters. Express d in terms of p and theta. So let's sketch this first. Here's our sector AOB. We have the radius shown on both sides because we're going to be discussing perimeter, and we have the arc length L and the angle theta of this sector. Now we know that the radius is half the diameter, and of course in this example, since the diameter is d centimeters, r is equal to d over 2 centimeters. Now the arc length is equal to r theta, as given by the formula. So if we plug in our value of r into this formula, we have that L is equal to d over 2 times theta. Now the perimeter of AOB is equal to p centimeters, and AOB, as we can see from the diagram, is equal to r plus L plus r, which is equal to 2r plus L. If we plug in the value of r equals d over 2 into the expression for p, we obtain that p is equal to d plus, and then plug in the value of L, which is d over 2 times theta, as shown. And if we factorize, we have that p is equal to d over 2 times 2 plus theta. And so we can rearrange this to obtain d equals 2p over 2 plus theta. This brings us to the end of this session. If you have understood its contents, you should be able to find an arc length using radians. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.